Hey everyone, welcome to the Fargo 3D printing show this week. Jake Clark, Zach, almost forgot your name, and John Schneider. I forgot your last name now. Triplett. Zach Triplett and John Schneider today on the podcast. Sorry. So we have a guest. Zach is our engineer, internal engineer, so he's our ME. So he does lot of our testing. So this week, we'll come back to you. So this week we announced Glass Filled PLA as one of our products. So John, you want to tell us a little bit about what the Glass Filled product is and kind of dive into the intro, and then what we'll do is actually come back and then we'll actually give Zach the floor, and he'll actually talk a lot about the testing side of things and diving into more of what those numbers actually mean and represent. So go ahead, John.
Yep, so Glass Filled PLA, some things to know about Glass Filled PLA. It's not a clear product, so that was one thing that we had some people asking us is, oh, that doesn't look like it's clear like glass would be. No, it's called Glass Filled filament because it actually has short glass fibers in it, and the short glass fibers mixed in with the PLA make it stronger, tougher, and more flexible than standard PLA. So if you're looking for something that's going to be a really durable 3D printed part, something that's going to be very strong, or something that's going to be very tough, Glass Filled PLA is a really good solution for that. So Zach has done a lot of testing to compare Glass Filled PLA to standard PLA, and Zach, you can go ahead and talk a little bit more about kind of what you found.
Okay, sounds good. So before I talk about Glass Filled PLA specifically, I'm going to kind of talk about how we get these different numbers about these mechanical properties. So the three properties that we focus on the most when we do our testing are strength, toughness, and flexibility. So a lot of people have heard of the term strength and toughness, and a lot of people have a general idea of what it means. But from a technical standpoint, strength is basically the amount of force that an object can withstand before breaking. So if you were to take this sample here and grip it here and here and pull, the point at which it breaks, the force required to break it, that's the strength of the material. Toughness, although it sounds similar to strength, is actually a different property altogether. It's the amount of energy that an object can absorb before it breaks. So think of strength as basically just pulling something until it breaks, whereas toughness would be like, say, dropping something on the ground. So if you took your phone and you have a phone case on it and you drop it on the ground, your phone case is absorbing energy rather than withstanding a force. And then the third property we talk about is flexibility. So flexibility can have two kind of different definitions. One of them is basically the amount of deformation that an item goes through when a force is applied. And then the other is the amount of deformation that something can actually withstand before it breaks. So when we say that glass filled is more flexible than PLA, what we're saying is that it can actually bend further before it breaks when compared to PLA. So now let's get into the numbers here. So the tensile strength of regular PLA is 41 megapascals, whereas the strength of glass-filled PLA is actually 57. So that's an increase of nearly 18 megapascals. The toughness of PLA is, where do I have that at? There we go, which is measured in joules per meter. So basically that's a unit of energy. Regular PLA is about 26 joules per meter of impact energy, where glass-filled is 34. So that's an increase of nearly 8 joules per meter. And then, like I said before, we're talking about flexibility. With our definition of flexibility, we're going to be using tensile elongation. And that's basically a percentage of the original length divided by the final length of the deformed object. So for PLA, that's 1.8%, and for glass fill, that's all the way at 3.4%. That's nearly double the tensile elongation of glass. So when you're using glass filled, it's a great material when you're worried about the strength or toughness of the product that you're printing. So I think in the video, there's an example of printing a bracket with glass, like a bracket for a shelf. That's a really good use of glass because it's stronger. or if you were printing, say, this right here is a fan, a blower fan, and that's a good use for glass because it'll actually undergo a lot of maybe not this particular one, but something that actually is being used often. It'll undergo a lot of internal stresses, and having that increased flexibility and strength will make it last a lot longer than a regular PLA piece. So.
Okay, very cool.
Yeah.
And so you've done a lot of test printing with this so far.
Yes, I've done a lot of test printing with glass. One of my favorite things about printing with glass is that the parts virtually don't warp at all. The glass fiber really holds the PLA in place while you're printing, and you don't get really any warp at all when you're doing your first layer. I didn't bring it down, but we have a really big four-pointed star that we printed on a MakerBot Z18, and it was stuck to the build surface the entire time. It was
actually
amazing.
kind of pulled up a little bit on the surface.
It was.
And that's a tough build plate to pull.
It actually a little bit pulled up on the corners of the build plate. Like, it adhered that well to the build surface. It was.
Yeah, it pulled up part of that plastic, and that, when you're sitting there and you pull on the plastic in the thing, you're like, oh, there's no way in hell this is moving. But it actually.
It has great bed adhesion and very, very low warp, virtually no warp. So those are probably two of my favorite, as well as bridge gapping or
bridging.
Gap bridging is really good too, because of the glass fibers in there, it actually prevents drooping of the material while it's running over a gap. So I really love printing with this material. It's one of my favorite materials I've ever printed with.
So any difficulties printing with this? I know supports are one thing.
Yeah. So if you're printing you can print with a raft very easily as long as you set the model raft separation distance higher than you would with normal PLA. But printing supports can be somewhat difficult. It's better if you have a slicer where you can place supports only where you need them, because of the interlayer adhesion and the lack of kind of movement that you get when you print an actual solid part, or not solid part like this, as opposed to 100% infill like I do with my test samples, is that it's going to be really tough to remove internal support material. So consider that when you're printing with it, but because you can bridge those gaps, you probably don't need much support anyway.
Okay. So very cool.
Yep.
And prints at the same temp as PLA.
Yeah, so you can print at basically the exact same print settings as you do with regular PLA, like I said before, except for the raft model separation distance.
Okay, and I think so far on the machines we've had in-house, we've printed them on Replicator 2s, Replicator Z18, Replicator 5th gen. I don't think we've done it on the Mini, but I assume it would be the exact, it's a smart extruder.
It's a smart extruder,
So it's going to be the same type of extruder. And then also the Lulzbot Mini, Lulzbot Taz. I think that's what we've had a chance to print on.
I haven't got a chance to print on anything other than those, but it prints well, both 3mm and 175 mil.
Okay, so cool. Well, yeah, I think that takes care of the glass filled PLA and kind of our testing method and that kind of stuff.
Yep.
So one thing that we're going to go into next is something new that we found out about Simplify3D.
And you were pretty excited about
this. Yeah, so this is
he was jumping out of his seat. He's like, "Oh my god, I got this!" I'm like, "What?"
Well, it doesn't sound like a big thing, but if you've ever downloaded an STL or you've designed an STL and you're trying to fit everything onto the build plate, best example that we have right now is we're importing models of a city block. So you have all these different buildings that we're trying to print buildings for basically a site plan for an architect. And there's a lot of open space. So where parking lots are, where streets are, you're not printing anything. We're only printing the building models. So that's a lot of wasted space on a build plate. So what you can do is, instead of printing just one 12-inch by 12-inch block with, let's say, 70% of the space wasted, you can actually separate all those buildings into separate movable pieces and then bring in other STL files and rearrange it so that it all fits onto the build plate. So in Simplify3D, the way that you do this is you go to Mesh and select Separate Connected Surfaces. This now separates it into separate objects that you can move around on the build plate, and then you can group them into a new object. So what I've done is I will click on Mesh, Separate Connected Surfaces, and then do Auto Arrange and Center, and that gets it pretty close. It still leaves a bit of a gap between each of the buildings, but you can manually place everything and have everything be much closer. So this has saved me, instead of having to go into Mesh Mixer and cutting it into 2 separate STL files, or many separate STL files, and then re-importing it and rearranging, I'm able to do all of this in one step. And this is also good if you are sent a file like we were, where it was 3 blocks all in one STL file. And I would have had to have gone in, separated those into separate blocks, and then each of those blocks into separate buildings, manually rearranged it. This way, I was able to go mesh, separate connected surfaces, auto arrange, and bring everything in. I mean, it's just slick. And I don't know if this is something that was new for Simplify3D, because I only discovered it about a week ago. And the way I discovered it, Simplify3D has a ton, well, not a ton, but they're finally starting to post videos on their YouTube channel. So go look at the Simplify3D YouTube channel, because there's a lot of features that I wasn't aware of that, I mean, just make it even more worth the $150. I mean, it's unfortunate. It really is unfortunate they don't have a trial version, because it is that good. If they could figure out a way to have a trial version, I mean, it's
14-day trial.
Yeah, it's just it's so good.
So Simplify3D, as you're watching this,
Yeah.
get a trial version.
Yes.
Because you'd sell so many more seats, because it's just that hump for people that to get over to spend the $150.
Well, yeah, and I mean, for a lot of people, they're hobbyists.
Yeah.
I mean, they have a $400 3D printer kit that they put together themselves. When you have a slicing software slicing softwares you can get for free, a lot of the open source stuff, they're good, but they don't have the same functionality that Simplify3D does. And then support generation. I mean, we've talked about support generation before. I mean, I could talk for an hour on support
You'd
generation.
be blue in your face, but you're already blue in the shirt, so
Yeah.
that's not getting any
Yeah,
farther
no,
than that.
yeah. Okay, so anyway, separate connected surfaces. We're also going to do, or at least I'm going to do another video that just goes in and talks about that and how awesome it is. I think we're going to,
So it's gonna be John nerding out for like 5 to 10 minutes.
Yeah.
You're gonna get a minute of content over 10 minutes because he's just so excited about it.
Well, you're going to know a lot about it after that 10 minutes. You're probably going to know more than you wanted to. But I mean, it's awesome. It's so cool.
Well, and we keep finding out new things, and they keep adding new things, and we keep seeing. It's really cool to see the development of the software, because a lot of the hardware out there is very well built, and it's the software is what is the missing link to a lot of 3D printers. A lot of them don't have a good slicing software where, Simplify3D kind of steps in and is a great software to bridge that.
Yeah, definitely. Yeah.
So.
Yeah, and then when we were looking over some other stuff, so kind of going back to the glass filled for just 1 second. So again, we weren't printing with like molten glass or anything like that. There's short glass fibers that are in the PLA filament. Although we did find that there's a printer out there that someone has, or there's an extruder that someone developed that can print glass, like full temperature, I mean, all the way up to borosilicate glass. That's like 1680 degrees Celsius.
Yeah.
So that's hot.
you.
Well, basically, it's an all metal extruder, and they have a blowtorch firing on the extruder at the same time, just to keep it hot enough. But as we were looking at that, Jake, you came across a printer that looks pretty awesome. Like, it looks like it'd be, yeah.
Yeah, it looks like it should be in a 1950s diner, sitting over at Kroll's. It is a beautiful, sexy machine. So, HotRod Henry is the 3D printer name.
What a great name.
I know. Well, it really, it's an original design, really, because if you look at like the old 1950s gasoline pumps and the jukebox from that era,
Coke machines,
refrigerators,
refrigerators.
yeah. So it should belong in our accountant's office, because he has a lot of older stuff like that.
Mid-modern.
This machine would fit right in. It's got the curves. It's got like the metal pieces with it. It just
Metal pieces. Well,
it's just,
no, I know.
Go look. I can't
it's really
explain how awesome this printer looks.
Yeah.
I mean, it's just amazing at what it. And anyway, so from its looks, it actually looks like it could perform. I don't know. April 3rd, 2015 is when I think it saw some of its first glimpses out in the wild.
Okay.
So there is no pricing for these machines right now, but you can inquire to get the pricing. So I'm going to do that and see what this machine runs. So I think it's relatively new to the market. I'm going to be skeptical on that. as it didn't really say when I was paging through a couple articles in their website. But when I was doing some research on it, there's a bunch of different machines. Lulzbot should watch out for this machine and the Z18 as well, because it can do PLA, ABS, NinjaFlex, copolymers, composites, HIPs, nylons, polycarbonate. It's a 350C hot end, all metal hot end.
Wow.
So the max temp is 350.
Okay.
So you can do a lot of different materials with that, including glass. And it doesn't have a heated chamber, but it does have a heated bed.
Well, and it's enclosed.
It's
isn't
enclosed.
It? Yeah. Well, I mean that's essentially a heated chamber. I mean, a heated bed's more important to me, I think, than a heated chamber, because that's
the chamber's nice to keep everything warm and cozy.
Well, yeah, but I mean, it's like the Z18. It has a heated chamber.
Yeah, an actual heated chamber.
Yeah, but then the bed plate's not heated, so it doesn't help a ton with adhesion. It helps with some other issues, which we could go into, but
yeah, helps with biome a little bit.
Well, and large flat surfaces using
Yes.
MakerBot Desktop, it helps with the rippling. I mean, you
can
really
toggle that now in the advanced settings.
Yep.
Okay, good.
But I've played with it a little bit with PLA. I think the highest you'd want to have the chamber is like 40 degrees Celsius. Or no, not Celsius. Celsius.
Yeah, I was gonna say.
Because I had it at 50 once, but
It's
I
like
think
40. You'd be cooling the chamber down if it was Fahrenheit.
at 50, 50 I think was a little bit too warm. I think 35 to 40 might be a sweet spot. But anyway, yeah.
So
Heated bed more important than heated chamber, I think.
yeah, but it's still
With a chamber,
it's
it makes it a
enclosed,
heated chamber.
and the build volume is actually a little bit bigger than the Z18. It's 13 and 3/4 by 13 3/4 by 23.5 inches. So 350 by 350 by 600 is the build volume. So
In millimeters?
Yes. So it's taller than the Z18, and it's a little bit wider in both directions. So it competes in that realm. So with the list of the different plastics you can run, now I don't know how well the NinjaFlex is going to run, if they have something similar to Lulzbot where it's like a flex extruder, or if you just put it in the same extruder and cross your fingers. I don't know.
And the big thing with that is just controlling the path all the way from the drive gear
Mechanism to
nozzle.
Because in a lot of, I know in Lulzbot's original in their original Budish nozzle, I think that's what it's called, the Budish nozzle. Anyway,
Something
their
like
original
that. Yeah,
extruder
sure.
design, there was just a little bit too much of a gap between the drive mechanism and the guide area. There wasn't like a tube that went all the way down, so it would kink up just a little bit. And so that was the problem with NinjaFlex. Semi-Flex will work just fine.
We've seen a little bit, and I'm sorry, I'm getting off topic on this, but on the Rep 2, we've actually had some cases where the PLA would come down and the barrier tube's not clogged, but what will happen is the PLA will actually suck around the tube or on the drive gear and then just get bundled up. So we've actually had that happen in our office a couple times. We've had a couple clients have that happen too. So really odd phenomenon, but it could be attributed to the same kind of deal with the distance, not the tube, but the distance. So go check out the HotRod Henry. We'll have photos. It's a really BA machine.
Do you know the name of the company that's making it?
It's II Labs. Yeah. So thank you, because I would have totally butchered that.
How are you? You're gonna say IA basically.
I don't even know.
II, like if you're in the Navy,
Captain.
that type of
Or SpongeBob.
yeah. AYE
Labs.com. Yes. So go check that out. I'm going to get some more information on it because I think it's a really neat printer. I'm hoping that it's at one of the shows we're going to be going to later this fall, so we can get an in-person look, get some up close. So I'm going to dig around their website. If you guys have more information out there on this machine, or know anything about it, or have one, leave those in the comments. Let us know how it's running, how it's working, what your thoughts are. Shoot us an email, send us pictures, videos, whatever you want. Because I want one. If it doesn't even work, I want one to set in the office just to have that conversation of
very, very practical use of company funds right there.
Yes. Well, Coke machine from the 50s. That's
anyway.
And if you try the glass filament or have bought the glass filament, definitely post pictures, ask us questions, get in touch with us. We'll get those answered. And
on behalf of myself, John Schneider, Zach Triplett, and Jake Clark, we want to thank you for tuning in to another episode of the Fargo 3D Printing Show. If you haven't already, subscribe to us on YouTube or on iTunes if you're listening to this, just the audio version. We're on a bunch of different social media channels, Facebook, Twitter, even Google+. So hit us up there. And if you have any questions or comments, leave them below. We're always interested in hearing what you guys have to say. And if we always want to address that stuff too. If you have any questions on how something works or anything you want us to cover in the future.
And share your prints on our Facebook page too, and we'll check them out.
Yeah. All right. Thanks again.
See ya.
Bye.
You always wrap up my wrap up.
I know.
Sound it out. John, could you?